All right, let's just jump right into this explainer. Today we're looking at Elsa. Now, Elsa is a brilliant 9-year-old mathematician, artist, and budding scientist. And like a lot of folks, she absolutely loved a very specific, highly controversial delicacy, shark fin soup. For her, it was all about that unique texture, not to mention it's a huge status symbol. But when someone she loved pointed out the massive ecological damage behind the dish, Elsa didn't just blindly accept it. Being the logical thinker she is, she actually formulated what she thought was a perfectly sound counterargument.
So, to really get Elsa's journey, we gotta look at that initial kind of flawed hypothesis. You see, she assumed sharks were just, well, the scary villains of the ocean. In her mind, removing them wouldn't cause any real harm. Actually, she figured it would make the ocean much safer for all the other fish out there. I mean, if you subtract the villain, the rest of the ecosystem thrives, right?
She just didn't see the harm at first. Her logic was super simple. There are millions of fish in the sea, and sharks are just scary predators anyway. Why does it matter if we catch them? But here's the thing about Elsa. She is a true scientist, and a true scientist knows you cannot rely on assumptions or, fairy tales about heroes and villains when you're dealing with complex ecosystems. To get the real truth, you've got to run the numbers.
Okay, so let's move right into the data. Section 1, the apex collapse simulation, testing the ecosystem equation.
So, Elsa boots up this highly advanced simulation of the ocean biome. She's looking at a digital ocean packed with thousands of species, all the way from apex sharks down to tiny bottom feeders. Then, she drops the shark population to absolutely zero. Now, she fully expected the smaller fish to basically throw a giant celebration, but instead, her screen just starts blinking red. Without those sharks, the ecosystem goes into a catastrophic cascading failure. Zero sharks leads to an overpopulation of medium fish, which totally depletes the small fish, and ultimately, you get a dead ocean.
And get this, the scale of the immediate disaster is just staggering. Without those apex predators there to keep everything in check, the population of medium-sized fish and rays absolutely explodes by an incredible 500%. It is a complete demographic takeover.
It's literally a domino effect, and it perfectly demonstrates how the entire mathematical equation of the sea just crashes right down to zero. Because there were 500% more medium fish, they ended up eating every single small fish, crab, and clam in the ocean. And with the small fish entirely gone, well, there was absolutely nothing left to eat the algae, so the algae just grows completely unchecked and suffocates the coral reefs. In just a few simulated years, this beautiful, thriving blue digital ocean turns into a slimy, dead, green desert. Total ecosystem collapse.
Staring at this completely dead digital ocean on her screen, Elsa's math brain quickly realized her massive error. Sharks are not the enemies of the ocean. Actually, scratch that. They are its essential managers. They act as these incredibly vital top predators, the stabilizers that keep the intricate marine food web perfectly balanced. Without them, the whole equation just falls apart. Which brings us to Section 2, the reality of the fin, the cruel mathematics of the catch.
So, after witnessing this digital simulation crash, Elsa decided she needed to research how real-life sharks are actually caught, and what she found completely horrified her. The reality is brutal and wildly inefficient. To save valuable room on fishing boats, fishermen will literally pull a live shark out of the water, slice off its dorsal fin with a hot knife, and then just throw the bleeding animal right back into the sea. Without its fins, it sinks down to the dark floor completely helpless, left to suffocate or basically be eaten alive.
Elsa came up with this stark mathematical comparison, and it really hits the nail on the head. Slicing the fin is exactly like taking the wings off an airplane and expecting it to fly. Without its fins, this beautiful, finely tuned biological machine is rendered entirely useless. It's just a terrible equation that ends in sheer devastation.
Looking at the hard data, it became mathematically and ethically crystal clear to Elsa that this was not smart science. It is a massive, highly inefficient waste of a magnificent creature, driven purely by human vanity. We're talking about a devastating ecological cost, all just to maintain a symbol of status.
Let's pivot here to our next section, the culinary biohack, solving the texture problem.
Now, Elsa had a real dilemma on her hands. She still absolutely loved the unique, stringy texture of the soup, but she firmly refused to destroy the marine food web to get it. Well, that weekend, her auntie introduced her to a really elegant, sustainable solution. Think of it this way. Traditional shark fin soup is mathematically disastrous and incredibly cruel. But on the flip side, we have shark fin melon soup. Zero ecological harm, it's a brilliant scientific biohack, and it still delivers that exact perfect gelatinous texture and snap.
So what exactly is this biohack? The shark fin melon is actually a special variety of gourd. And when you slow cook it in a really rich broth, its natural flesh separates into these beautiful, translucent, gelatinous strands. Nature and science had literally already provided the perfect alternative. When Elsa finally took a spoonful, she realized the texture was absolutely identical. I mean, it looked, felt, and snapped exactly like real shark fin.
And that leads perfectly into our final section, Defender of the Deep, a smarter equation. Elsa realized that we don't need to torture these magnificent creatures or crash an entire ecosystem just to enjoy a specific texture. Empowered by this discovery, she totally transformed. She marched over to her art desk and drew this majestic hammerhead shark swimming over a thriving reef. And right at the top, she summarized everything with a brand new, beautifully simple formula. Protect the apex, choose the melon. Because you see, the true mark of a scientist isn't just running the numbers. It's actually changing your behavior when the data tells you that your current equation is broken. So as we close out this explainer, I really want to leave you with a question. What hidden mathematical costs are lurking in your own daily choices? And more importantly, what smart biohacks can you choose instead to upgrade your equations and help protect our planet? Definitely something to think about.